Our goal in this video is to talk about finding the distance between a point and a line. So I've gone ahead and randomly generated a line and a point that we're going to work with. So I'll go ahead and write those down. This is y equals negative 1/4 x plus 9. And then the point that I'm going to be working with is the point negative 2, 2. So the first thing I'm going to do is I'm going to give this a quick sketch so we can see what's going on exactly. And after we do that, we're going to talk about the strategy here for how I'm going to work through this. So my line, negative 1/4 x plus 9, has a y-intercept up here at 9, and then has a pretty not steep but negative slope. So it's going to look something like this. And then my point negative 2, 2 is going to be somewhere down here. Okay, so how can I find the distance between a point and a line? Well, first off, we need to talk about what does it mean to be a distance between a point and a line. Because I can find, for example, if I want to find the distance from the point to this point on a line, this is obviously not the shortest distance from that point to this line. And so there's actually infinitely many different distances from the point to the line. But so when I say the distance from my point to the line, what I'm talking about is the shortest distance from that point to the line. And so the question is, where is that exactly? And the answer is, well, if you think about like standing in a room and you're trying to get to a wall as quickly as possible, you're not going to run to one of the corners. You're going to run to that place that's the shortest distance that is actually perpendicular to the wall that you're running towards. And so that's going to be my goal here, is that I'm going to find this perpendicular distance to this line, and that's going to be my shortest distance. So I'm going to write down my strategy here. There are 3 steps, essentially, that I'm going to be working with. Step number 1 is that I'm going to try and find the perpendicular line. Find the perpendicular line. And once I do that, I'm going to find that intersection point between my perpendicular line and my find intersection point and my original line. And then the last thing that I'm going to do is I will actually find that distance using the distance formula. So those are the 3 big steps I'm going to take here, and we're just going to knock them out one by one. So let's go ahead and start with finding the equation of this line. So I'm going to switch to blue. Let me draw this in, give it a rough sketch here. So I'm trying to find this line here, essentially. So this line that's perpendicular with my original. Let me write down the information that I know first. So the line that I'm working with is y equals negative 1/4 x plus 9. The point that I care about is the point negative 2, 2. And then my perpendicular line, this is the first piece of information that I'm going to have to figure out. Perpendicular line. Okay, so what do I know about my perpendicular line? Well, I know a point that it goes through. It goes through a point negative 2, 2. And then I know the slope of it as well, which may not be obvious. But what I do know about perpendicular lines is that 2 lines that are perpendicular to each other will always have opposite reciprocal slope. So in this case, I have the line y equals negative 1/4 x plus 9. So my new line will have opposite reciprocal slope to the negative 1/4. So it will be a slope of 4. So if I know both my slope and a point that it goes through, probably would be most advantageous for me to use this point slope form to find the equation of this new line. So I will do that. Y and then minus y1, so minus 2, will be equal to the slope 4 times x minus, and then x1, which is negative 2, so plus 2. I'm going to go ahead and put this into slope-intercept form just because it's going to make it easier for me here in a second, and you'll see why. So this is the line y equals 4x plus 8, and then plus 2, so plus 10. All right, perfect. Okay, so this is my equation of my perpendicular line. So next thing that I want to do, and I'll do it in a different color here, is I want to find this intersection point. So I have to ask myself, like, what does it mean to be an intersection point in the first place? And what an intersection point is just the one point that satisfies both of these equations, right? It's the one point that I can plug into either of these and makes them both true. So in other words, I'm trying to find the solution to this system. So I want to solve solve the system, y equals negative 1/4 x plus 9, and y equals 4x plus 10. These are two lines that are intersecting. I want to find that point of intersection. So these are ready-made set up for me to solve using substitution. I have negative 1/4 x plus 9 is equal to y, and I have 4x plus 10 is equal to y, so I can just set those equal to each other. And so I'll have negative 1/4 x plus 9 will be equal to 4x plus 10. So I will get all my x's on one side. Let's put them all over here. And so I will have, so this is 16/4, so now I have 17/4 x. I will subtract the 10. That'll be equal to negative 1. All right, so this is not going to give me a nice point. That's okay. All right, so then x will be equal to negative 4/17. So now I can plug this back into either of these equations. They should both give me the same thing to find y. If I plug into this one here, what I will get is, so I have, let's see, 4 times, so I guess I'm really plugging into this one here. So I will have negative 16/17 plus 170/17. So that would be 154/17. Seems right. Okay, let me double check that. So 4 times this, so negative 16/17 plus 10, which is 170/17. 170 minus 16 is 154. Okay, so not a nice point at all, but that's okay. This is my intersection point, negative 4/17, comma 154/17. Okay, this is what I get for randomly generating a problem. So now that I have this point of intersection, I can actually go and find my distance now. So I have my 2 points. I have my 2 points of negative 2, 2, and then negative 4/17, comma 154/17. I want to find the distance between these 2 points, and so I will do that by using the distance formula. And so it tells me that the distance is just equal to the square root of, and then the change in my x value, so negative 2 minus, and then plus 4/17 squared, plus, and then I have 2 minus 154/17. Okay, so I'll be honest, I don't want to make an arithmetic here, so I'm going to break out my calculator. So I have negative 2 plus 4/17, which I really should be able to do. That's just going to be, what, 30/17? But let's confirm. Yes, so negative 30/17. So negative 30/17, that quantity squared, plus, and then 2 minus, I'm not even going to try, 2 minus 154/17 is negative 120/17 squared. All right, so what's that's equal to? I'm going to square both of these. So I'll take this value and square it. And I get, this is square root of, let's see, 900 over 289. I guess I could have done that in my head. Oh well. Plus, and then I'll square the other one, squared. And I get, all right, a doozy, 14,400 over 289. All right, if I add those together, what I get is this plus this is 900 over, oh interesting, 900 over 17. That doesn't seem right. That's okay, I'll take it. The square root of 900 over 17, of which then I can simplify to, okay, so I can take the square root of 900, which is just 30 over root 17, but I'm going to rationalize this and get 30 root 17 over 17. And just for kicks, I'm going to see what this is roughly. It is roughly 7.276. 7.276. And the reason I'm checking that, just to see roughly what it is is, does that make sense in the context of my problem here? Well, so I have the point negative 2, 2. The intersection is going to be like right above where the y-intercept is, which is about 9. So yeah, 7 point something, that makes sense. And so I just want to check to make sure it makes sense in the context of my problem. However, the answer that I want to, of course, give is this 30 root 17 over 17 answer. That's my exact value for the distance between this point and this line. So just to recap really quick what all happened here. We were given the equation of this line and this point. We decided we want to find the distance between them. The distance that we're going to find is the shortest distance, which is along this perpendicular line. So what I did was I found the equation of the perpendicular line using the line, or the point that it went through, and the slope, which is the opposite reciprocal of the line that I had, or the slope of the line that I had initially. What I then did was I wanted to find this intersection point by solving this system of equations. When I did that, I got this not so great point here of negative 4/17, 154/17. And so then I just used my distance formula to find the distance between that point and my initial point that I had, that I started with. I did that, I simplified everything, I got 30 root 17 over 17. I gave myself a rough approximation of what that is, 7.276. I looked back at my graph, and that made sense in the context of the problem. So 30 root 17 over 17, I'm happy with that. So it's kind of a long process, and there's formulas out there exist for this, of course, as well. But really, if I want to get an understanding of what's going on between, or for finding the distance between a point and a line, this is how I do it. And so I can repeat this process in the future if I ever want to find the distance between a point and any line.